All right, what's going on YouTube? My name is Anthony Merlin, and this is my first video. As y'all know, well, actually, y'all don't know. If y'all read the description, the videos I'm going to be providing are math, some science stuff maybe, some video games, anime, really just stuff I like. And yeah, and I really welcome y'all to my channel. And if y'all like what y'all see, leave a thumbs up. Who knows? I don't know. Anyway, let's get into it. So what we're going to be looking at is some vector and matrix norms. Some examples involving them. And the subject this underlines is numerical analysis. Sorry about that. Love this drink. And for numerical, just have a good linear background, some calc, and maybe some DiffyQ stuff. Anyway, let's get right into it. Starting off with this example. So we have this matrix that maps complex plane 2, or squared, to complex plane 2. It also maps R2 to R2, which is more convenient if we want to draw pictures. And it can also be shown to be sufficient for determining matrix P norms, since the coefficients of A are real. Now, figure 3.1, this is a property, and figure 3.1 basically goes, the first one determines, in order for it to be a vector norm, it can't be less than 0. It is less than or equal to 0. And if it is 0, then the vector inside the norm is a zero vector. Sorry. Hopefully that made sense. Anyway, figure 3.1 property depicts an action of A on the unit balls of R2 defined by 1, 2, and infinity norms. From the figure, one can see a graphical interpretation of these 3 norms of A. Regardless of the norm, A maps E1, which is 1, 0, adjoint to the first column of A, namely E1 itself, due to, and E2, which is equal to 0, 1, adjoint to the second column of A, namely 2, 2. And in the first norm, the unit vector of X that is amplified most by A is 0, 1, adjoint, or it's negative. And the amplification factor is 4, which we'll see when we draw this out, and you can maybe see geometrically. In the infinity norm, the unit vector that's amplified most by A is 1, 1, adjoint. Again, you'll see it. And the amplification factor is 3. And in the 2 norm, the unit vector that's amplified most by A is, let me make sure, A is the unit vector, okay, actually this is because I need to change this. I'm so sorry. Yikes, first video. Oh, okay. A is the vector, so good thing we got a good old eraser. All right. So we can go back right here. In the 2 norm, the unit vector that is amplified most by A is the vector, indicated by the dashed line in the figure, which we will draw out. Or it's negative yeah. And the amplification, and some of my spelling might be just actually trash in this, and I apologize. We're gonna focus on the process here. So approximately 2.9. Again, this will make 100 more sense in our figure. Note that it must be at least 2.8284. Cool. And since 0, 1 adjoint maps to 2 adjoint, yeah, I wanna get this clear. We shall consider how to calculate such 2 norm results in a later video. Okay, so that was a lot, and I'm going to zoom out a little bit. If y'all know who this is, legendary. Anyway, but this is just a good overview of what we just talked about. So pause if you need to or whatever, and let's get on to it. So like I promised y'all, what is the, oops, going the opposite way. So, we're going to look at our interpretation. So our 1 norm, we're gonna draw out like this guy, little diamond with a solid and non-solid here. And we can write our adjoints. Perfect. And yeah, and this is, as y'all notice, this is pretty much really identical to a vector norm, which we're gonna, well, actually we're not going to look at, but for those who are interested, yeah, we'll just do it real quick. This is what so we have say a 1 vector norm, and we can write out the summation, just I equals 1, I, and this is that. So really, literally the exact same thing, nothing too fancy. And as we convert this, we are going to have, oh my gosh, bear with me, something like this. Okay, not too shabby. Well, actually it's pretty rough, but there's our 2 adjoint due to the matrix. And lastly, we can state this. Matrix 1 norm is 4, as we said before. Awesome. Yeah, let's move on to the next one. So we did our over here. Oh my goodness, not this side. Over here, we did look at a a1 to an infinity norm. Sorry about that. So back to our 2 norm. Draw a circle. And as I didn't say this. Like this one, and it's identical to vector norm stuff, so we can assume that. And with the matrix, we get a something like that. Yeah, that looks good. Perfect. And we can determine that as 2 norm. Or I said before, so make it like that. And last one, our infinity norm. And so this one reaches out. Cool. So it literally just transforms the objects. And we can state this. Cool. 3 as we said. And yeah. Yeah. Well, based on this, we can write on the left the unit balls of O2 with respect to norm 1, norm 2, and norm infinity. And on the right, their images under matrix A, which was our original matrix we saw in the question, which was that guy. Cool. And the dashed lines mark the vectors that are amplified most by A in each norm. So pretty cool. And yeah, that's our first example, guys. Very cool stuff. Let's move on to the next. Next one we are looking at, we can say sample 2.2. The P norm of a diagonal matrix. And we're gonna let D be the diagonal matrix. Oh, perfect. It's like to have a water. Great value. Oh wait, not even great value. back to this, we're gonna let, D be the diagonal matrix. Perfect. Which we are going to make this. Sorry about that. D1, T2, all the way to DM. The DMs. Then, as in the second row of figure, oh goodness, gotta get in the camera. Figure 3.1, the image of the 2 norm unit sphere, which is the same as the sphere we saw there under D, is an M dimensional ellipse. I was wondering what that term was. I don't know, like my head was kind of just like, what is that? Whose semi-axis lengths are given by the numbers di, which we can, obviously, cool. The unit vectors amplified most by D are those that are mapped to the longest